Hey everybody, Josh here. Welcome back to my channel. And today we're going to be covering integrity. That is the integrity that's part of the CIA triad, being confidentiality, integrity, and availability. These are the three main pillars in information security. Most of what we do as defenders kind of falls within these three pillars. So confidentiality is just making sure data or information remains confidential and protected from those who are not supposed to see it. Availability is essentially ensuring that systems remain online and accessible to those who need them. And integrity refers to maintaining consistency and trustworthiness of data. That is, making sure data doesn't get changed when it's not supposed to be changed. And if it does get changed, some kind of alert or something is raised so an analyst or someone can investigate the change. So again, today's video is going to be on integrity. We're going to do a demo that will hopefully give you a better intuition of what integrity actually means in cybersecurity. In order to do this, we're going to create in PowerShell a really simple FIM, and FIM stands for File Integrity Monitor. A FIM is basically just an application that monitors some important files and has the ability to raise some kind of alert once one of those critical files have changed. You'll see FIMs referenced a lot in a lot of framework and compliance documentation. For example, in PCI DSS or Payment Card Industry Data Security Standard, you'll see FIM referenced in a couple of the controls here. So basically, we're going to build a FIM in PowerShell and then do a little demo on it, and I'll show you how it works, and hopefully you'll be able to gain a better understanding of integrity in general and how FIMs work at the end of this video. You can also take the code from this and take it for yourself and make it your own and maybe like expand on it a little bit, put it in your portfolio. So going into a kind of high level overview of what our application is going to be doing, I'll just go through and explain this really quick before we jump into the code, just so you have an idea of what we're going to be building. So pretty much we're just going to have a basic file integrity monitor. It's really simple. Basically, when we start it up, when we run the script, it's essentially going to ask the user like what they want to do. Do they want to collect a new baseline or actually begin monitoring the files with an existing baseline? If we say that we want to collect a new baseline, our program's actually going to look into the folder where we're monitoring the files, and it's gonna collect all the hashes for the files. If you don't know what file hashing is, it's basically taking a digital thumbprint of each file, and it's gonna store that in a baseline text file, so we know what the digital thumbprint is supposed to look like. I made a video on hashing that really goes in depth. If you have no idea what hashing is, now check out this video. It's pretty useful. I explain it in depth, but basically it's going to take the digital thumbprint of each file as it is right now and then store it in a text file, and that baseline.txt file, it's going to look something like this. It'll have like the name of the file path with its corresponding hash. And the idea is if anything about the file changes, like even a little bit, the thumbprint or the hash, the resulting hash, is going to be totally different. So the idea is when we collect a baseline, the FIM looks at all of our files, gathers up the hashes for them, and then stores them in a baseline text file that we can use in the future to kind of check the files to make sure nothing is compared. So after we have our baseline file with the hashes, say we start the program again, asks us what we want to do, and then we say we want to begin monitoring our files with our saved baseline. So when we choose this option, the program will then load the baseline text hash files into a dictionary, which is basically a data structure that will store the value, in our case the file name, which is a data structure, which in our case will store the key, which is the file name down here, with its corresponding value, which is the hash. It will store all these key value pairs in the baseline.txt file into a dictionary or hash table, and it will then continuously loop through these files here and check each file and make sure that calculate the hash for each one of these and make sure that the hash still matches the hash in the baseline. If one of the hashes ends up being different, our program's going to print something on the screen like notifying the user or the admin or whatever that a file has changed. Of course, there's much better ways to implement this, but this is just a high-level proof of concept to help you kind of understand what integrity is and kind of drill that idea into our brains. So now that we kind of know at a high level what our program is going to do, we'll just jump right into the coding part of this. Hey, I'm kind of recording this after the fact. I just want to say before we jump into the coding section that as I'm coding, it's going to look like I'm like coding pretty fast, but that's just because I cut out like a lot of the dead time when I was like thinking and not doing anything, because otherwise the video is going to be like too long. So I can't really code this fast, and it looks like I'm like better than I am because of that. So I just want to say, like, don't let that illusion fool you. It looks like I'm like going really fast, but it's just because I cut out a lot of the dead space. Also, like PowerShell is kind of currently my primary language, so I'm kind of used used to doing it. So if I were to do this in like Java or something like this that I haven't really used in a while, there would be like a lot more Googling, but I did forget how to do some stuff and I did Google something. So this is like pretty realistic. I just kind of coded this off the top of my head. It seems like it's fast because I just cut out a lot of the dead space. But yeah, I just wanted to say that. Don't be tricked. I'm not that fast. Also, I didn't do like a lot of really best practice things too. So if you're like, why'd you do that? Like, I mean, that's because I'm like talking and I'm like already tired, but feel free to like, leave comments and stuff. Okay, back to the video. So we're just going to go ahead and open PowerShell ICE. We'll bring this over here and I will kind of move myself out of the way here. So there's a lot of ways that we can implement this. I'm just going to kind of implement it like in terms of how we organized our flow chart here. So I'm going to kind of start here and then do this, and then I'll code this part too. So I'll put a link to this in the description if you want to like keep looking at it. But so the first thing I'll do is we're just going to ask the user like what they want to do, like collect a new baseline or begin monitoring files with a saved baseline. So I'll just do this. There's like way better ways to implement all this, but just have cut me some slack here. So we'll say A for, and then for example, like I don't remember actually how to get input from users in PowerShell. So this is a scenario where I might Google, or actually maybe I think read host can. So let me make sure if this is the right way. Test read host. Maybe this is correct, and then we'll write whatever came back to the screen to make sure it works. Maybe I'll put a more appropriate variable name for this. So we'll just run this. It's always good to like keep running it and testing and running and testing. So I'll just save this here. FIM.ps1. So we'll just run this. So we have, what would you like to do? Collect baseline, begin monitoring, please enter A or B. I'll enter X. User entered X. Okay, cool. So that's correct. I guess read host. This is how to read input in from the command line. And I'm lazy. I don't know how to do like the string interpolated line break. So I'm just gonna put like an empty thing up here so it's easier to read. You run this one more time. What would you like to do? X. Okay, this looks correct. Okay. And I'm not going to do like a whole bunch of like error checking. I'm just going to assume that the user entered proper input because it's going to take like forever if I properly implement all those things. So I'll just say, and then we want to say like if user enters A, we're going to collect a new baseline. If user enters B, we're going to begin monitoring files with saved baseline. So we'll say if response, this is how to do equals in PowerShell, by the way, equals A. We'll say A to upper. So if they enter a lowercase a, it will be like automatically read as an uppercase A. So if we're going to say if response equals A, then we're going to, I'll just put a comment in here. If it equals A, we're going to calculate hash and store in baseline.text. And we'll say, I think this is how to do it. Else if, oh, that was not right. Response equals B, we'll say to upper. Oh my God, come on. And if response equals B, we're going to begin monitoring files with saved baseline. So I'll just test this as it is right now. Again, you always like test stuff like over and over again. So I'm just gonna do a simple write host. I'll say calculate hashes, make new baseline.text, and for this one we're gonna say read existing baseline.text, start monitoring files. That makes sense. So we'll test this. I'll just do something interesting here. I'll do some colors. Okay, so we'll run this again. I'll put some more spaces for readability in here. Okay, so I'll run this. And then we have, what would you like to do? A, collect baseline. B, begin monitoring files. Please enter A or B. So right now, we're stuck at this spot right here, and it's waiting for our response. So if we enter A, it should print this. If we enter B, it should print this. So I'll test both cases. So A, calculate hashes, cyan, looks good. I'll run this again, enter B, read existing baseline, start monitoring files. So this looks good so far. Cool. I'll implement this function here, like calculate hash value from targets, store file hash pairs in baseline.text. So I will, let me see. Let me think of the best way to do this. I'll make a new function that calculates the hash file. So I will say function I think I remember how to make a function in PowerShell. We'll see. So we'll call it, we'll just call it calculate file hash. And then for the parameters, we'll put like file path. So what this is going to do is going to take this file path, calculate the hash for it, and then return that hash value. So we'll do, I think it's get file hash, but if you can't remember any PowerShell commands, you can always say like get command hash, for example, and then you'll see like, you know, get file hash. So we'll say get file hash, and then path will just be file path, and then algorithm we're going to use, we can use any of these realistically, but I'll just be like hardcore and use SHA-512, and then I'll assign this to a variable, so file hash, and then I believe I can just do this file hash, return file hash. Okay, so we have a function that actually returns the file hash, so we can test that by doing something like this. So actually I made a bunch of like test files in here, and they're just like a.text, and it has a bunch of a's in it. So I'll get these file paths. I'll just test this function out. And we can do something like really simple, like I think we can do calculate file hash, and then we can just do something like this and pass the path into it, and then this function should execute on this, like get file hash for path, which is going to be this, which is what we passed in, and we'll return it, and it should print it to the screen. So if you just highlight this, you can highlight chunks of code in PowerShell and just run it. So I'll just run this, and if you, instead of clicking run, if you click this, it runs only the selected code. So I'll do this, and it looks like it ran, it got the file hash, and it just printed it to the screen. So we can do something like this. So instead of printing it to the screen, it will store it to a variable. I'm just testing it, by the way, so we can do this. So stored it in a variable. Now we can use the variable, and we can kind of look at the hash. So it looks like inside of the variable, it's stored like, it's an object, which has like algorithm, hash, and then path. So this is actually what we're going to use to store in our baseline.txt file. So it looks like our function is working correctly. So I will just get rid of this thing that I was testing, and then we'll go back to this kind of if-else statement. And we're going to say calculate hash from the target files and store them in baseline.txt. So basically what we want to do is we want to collect all the files that's in our directory that we want to monitor. And I didn't talk about this yet, but basically there's a folder that's called FIM, and this is our script that's inside. And then just for this proof of concept, there'll be a folder in here called files. These are the files that we're going to ultimately monitor. So basically what we want to do is with this block of code right here, we want to look inside of this files folder here, and then collect all the hashes from these, and then kind of store them in a text file that has like the path and then the file hash with it. So what we need to do first is we need to collect all the files in the target folder, and then for each file, calculate the hash and write it to baseline.txt. Cool. So in order to collect all the files, I'll just make a variable called files, and then we can just say like get child item, and we can say path. And actually, I'm going to browse to our FIM folder down here. So that's just on the desktop. So I'll say cd desktop and then cd FIM. So I'll say files, get child item, path, and then the path should be files. Cool. So I'm just going to run this line of code just to like make sure it's working. So it should collect the files here, and then it should print them out here. So we will try that. Highlight both of these, and I'll click run selected lines, and it looks like that worked. So it gathered the files and then printed them here. So it looks like it's working. So we're going to say, we're going to use our files variable, and it says for each file, calculate hash and write to baseline.txt. So we'll use a for each loop. So we'll say for each, you could say whatever, f in files, and then we're going to do something to them. So for each f in file, we're going to, let's first just calculate the hash and make sure that it works. So we'll use this for each f in file, calculate file hash, f. And actually, I'm not sure. Let me just make sure what f actually is. So I'm just going to run this first. I'll run this. So it looks like f just prints out like this thing. So let me see. We want like the full path of the file. So maybe full name, I think. So let's try this. Yes, this is what we want. So we want this, and then we want to use this. We want to pass this to our calculate file hash function. So I'm going to say, we'll say calculate file hash, and we'll pass in the full name, and we'll just see like what comes out with this now. Cool. So this actually looks good. So I only want this. I only want the path and then the hash as well. So we're going to do, I'll store this in like a variable called hash. And then for each one of these, I'll store this in baseline.text. So we'll say hash. So actually we'll do this. We want it to look like this, remember, like the full path and then the hash like right after it. The full path and then a pipe and then the hash right after it. So we'll say hash.path and then we'll say hash.hash, I believe. And then I'll see what this looks like. I'll run this one more time. And this looks right. It looks kind of janky because the screen is like too small, but you can see this is like the file path, and then this is the complete hash for that one. And then the next one, the file path, and then the hash. So this is what we want. We just have to store this in a file here called baseline.text. So we're just going to go, instead of printing it to the screen, we're going to put it out to a file. So we'll say out file, we'll say file path, and then we'll just put it in the current directory, and we'll just call it baseline.text. And then we want to append it so it doesn't keep overwriting the file. So we will just save this, and I will just run this code just to make sure it works. So we'll run this, and then we'll look inside of our folder here, our FIM folder, and we can see baseline here. And this is just what we wanted. So for each file, we have like the file name, and then we have the corresponding hash and then we have its corresponding hash for each one. So cool. But we'll notice something is like messed up. For example, if we run this again and look at this baseline again, it just like appends to it, right? It just keeps adding to it. So we don't really want to do that. There's like a lot of ways to like properly implement and fix this, but I'm just gonna like I'll just erase this file if it already exists at the beginning of our program. So for example, I'll minimize these. I'll make a new function called erase baseline if already exists. And then we'll just say something like, we'll say if, I think this is, oh God, I forget what it is. So in this case, I'm going to Google because I don't remember how to check if a file exists. It's something really simple, but I can't remember what it is, unfortunately. So this is where the Googling comes in. I feel like it's file exists. How to check if file exists. PowerShell. Oh God, I think it's file or object exists. I guess we're about to find out. Test path. Oh my God, I knew it. Okay, so I'll just test it down here. Actually, I'll do it here. So test path baseline.text just to see like what it returns. So I'll run this right here, only this line, and it returned true because it existed. So we'll say baseline exists like this. So we'll say if baseline exists, delete it. I think it's just remove item. Oh my God, it's not. Delete item, remove item. It is, nice. Path, we'll just do this, remove item path baseline. So erase baseline if already exists. So we'll just run this function at the beginning of our thing here. So we'll go back in here and I'll just add it here at the top of this. Delete baseline if it already exists. Let's do this. Cool. So now if we run this, I'll run it from the beginning. It should ask us these questions like what we want to do. If we say A, it should erase our existing baseline.text here, and it should step through like each file and get the name and hash, and it should create a new baseline.text with only 4 lines. So I'll go ahead and run this one more time here. It says please enter A or B. A is for collect new baseline. Actually, let me add this thing in here so it's like easier to read. Let me run this again. See, it's much easier to read. So I'll enter A for collect new baseline, and it did everything and then exited. So we'll check out our baseline. There should be only 4 because it erased the old one and made us a new baseline. So I'll just close this and I'll test this by like adding another file here. I'll just add e.text and I'll just put like some e's in here just to test it. I'll run this again. What would you like to do? Collect new baseline. I'll just say A. I'll say lowercase this time. And I will check our folder, check the baselines. There's only 5 here. And we have an E here and our corresponding hash. So cool. Everything is working so far. So if we kind of review our flowchart here, we kind of implemented the first part of this. We implemented A. We calculated the hash and then stored the hash in the baseline.text. So next, we're going to put logic for if the user enters B. We're going to kind of load, the first thing we have to do is load the file hash pairs from the baseline.text and store it in a dictionary. So we'll just go ahead and do that first before we get ahead of ourselves too much. So we're going to say if the response equals B, we are going to load file hash from baseline.text and store them in a dictionary. And a dictionary is just a data structure in a lot of languages. You can kind of think about it like as a normal dictionary, right? You have the key, which is the word you want to look up, and then you have the value, which is essentially the definition in the dictionary. So in our case, our dictionary is just going to hold the key, which is the file path, and then the value, which is the corresponding hash to it. So I totally forget how to make a dictionary in PowerShell. I'm not even going to try to do it. I'm just going to go straight to Google to save time. So actually, let me make sure I'm going to Google first. How to make dictionary in PowerShell. I guess it's called hash tables in PowerShell. And I think it's this. I believe it's this. So we can say, we'll say file hash dictionary. So I think we can do this and make an empty one, but let me just test it. Actually, I'll just name it this. It's too, no, I'll name it a proper name. You're supposed to name your variables like something good. So I'll do this. And I think you can add. So I'll add and path. I'm not sure if this is like how to do it, but we'll find out here. So I'm just going to run these 3 lines of code. It should make a new empty dictionary, add a key value pair, and then print it to the screen. So I'm not sure if it will work. Name, yeah, it does work. Okay, and then to read them, I think you can do this. Actually, I think it's this. Oh my god, I can't remember. Path. So this should pull out the value that's in path, which should be hash, and it did. Okay, cool. Okay, and let me see what happens when you enter like a key that doesn't exist, just so I can get an intuition for how this functions in PowerShell. It looks like nothing came out. Then I'll see if does this equal null or is it empty string or what? So I'll see what this does. It looks like it equals null when it's empty. Let me see if it equals empty string as well. It doesn't equal empty string. So when you look for a key that doesn't exist, it returns null apparently. And this $ null in PowerShell, this is a special variable. Just means null. You can probably Google it and find a more rigorous answer than that. Okay, so basically we're going to load all of the files from our baseline.txt here, or all the lines from it anyway, and then we're going to store them in our dictionary, if that makes sense. So to do that, we're going to say load hash file. So we're going to create, so I'll move this up here, our empty dictionary. Again, there's a lot of better ways to implement this, but I'm just gonna kind of do this because it's probably easy to understand. So load files. So we want to get all the content essentially from this text file. So we're going to say we're going to store them in a variable called file paths and hashes, and we're going to use this command called get content. And this will read in all the text line by line from our baselines file. So we'll read it from the path, which is baseline.txt. And just to test this out, I'll kind of file path. Oh my god, file paths and hashes. So I'll read them in, and then I'll kind of inspect this variable just to make sure it's working properly. So I'll just execute these 2 lines, and looks like it is. Read them in, printed all of them to the screen. So that's great. So this has multiple lines, so we can use a for each loop again. So we'll say for each, we'll say f in this, and we can say we're just gonna make sure this works again. So I'll just print f to the screen. So we'll do this, run this. And looks like it works still. So what we want to do, we want to add these entries here, this file path and then the hash. We want to add these as this will be the key in our dictionary and this will be the value. So we want to split this by the pipe. So we'll say, I don't remember how to do this, but I think it's split. Oh, it is. So we'll use the split command, which will split this string by whatever character we put in here. So we'll split it by the pipe, and this ends up returning an array. So the 0th element of the array it should be the file path, and the first element of the array should be the hash. So if we just kind of run this with the 0th element, it should just print out the file path for everything. So we'll test this out. Prints out all the file paths, and if we do 1, we'll just test this. It should print out all the hashes, and it does. So we're good to go. So we're going to use our kind of new objects here, and we will add these to our dictionary like we did here. So we'll take our dictionary, we'll say .add, and remember the 0th element is going to be the file path, and then the first element is going to be the actual hash. So I will get rid of this stuff. And then I will run this again. I will clear out the dictionary, collect the paths and hashes, add each path and hash to the dictionary, and then in the end, we'll kind of inspect the dictionary. So I'll just run this, and then now this variable has all the paths and hashes in it. So I'll just run this to look at the dictionary. And sure enough, we can see it here. We can do, just to look at it, we can do .keys, for example, to see the keys. Just run this, see all the keys, and we can do .values to check out all the values and all the values. So we're good to go. We have our dictionary, and it has all the keys populated with the values, keys being the file paths, and then the values being the hashes that correspond to that. So we essentially made a data structure out of this flat text file, if that makes sense. So this is our data structure. So what we want to do now is kind of use this to continuously check. We'll use the keys and values in here, and we'll kind of continuously calculate the hashes on all of these files and make sure that they always match the values that are in our dictionary, our baseline dictionary. Oh crap. And for example, if one of the values of these change, like the hash value changes, we have to like notify the user somehow. So we'll print something to the screen. So for now, again, there's much better ways to implement this, but I'm just going to add an infinite loop that sleeps and then checks like every second to see if the files have changed. So we're just going to say something crazy like, we'll say, actually, we'll use this continuously. So we'll say something like, we'll use a while loop that just runs forever. So while true, this just means a loop that runs indefinitely. Again, better ways to implement this, but this is easy to understand. And I don't want it to like just run so fast. So I want to put like a sleeper in between. So it like waits every second. And I remember because I've done this so many times in PowerShell, it's just start sleep. So we'll say seconds. So we'll just say like 1 second. And then I'm just going to do like a test checking if files match, just to make sure this works. So actually, I'm just gonna run this whole program. So I'll just run this whole program. What do you want to do, A or B? So I'm just gonna say B, begin monitoring files with saved baseline. So that's what we're checking. And then all this code executed, our data structure was built, and then this kind of section finished, and then we jumped into our infinite loop here, and then it waits a second and say checking if files match, waits a second, checking if files match, and it just keeps doing that. You can kind of see that happening down here. So this will run forever. So I'm just going to stop it. And because we know our thing is working, so we're good to go. So basically what we're going to do now is calculate in this infinite loop. We're going to calculate the file hash for like all of these. And then when we get a hash, we're going to check inside of our dictionary here. And we're going to see, first of all, if the key exists. If it doesn't exist, we know a file was deleted. And if it does exist, but the hash is different, then we'll know the file has changed. So we're going to use our, We're going to use our handy calculate file hash function. So I think I did that somewhere already. So we'll copy this. So here, so I'm going to borrow this code again. Again, not the best practice. You should modularize it and make functions so you don't duplicate code, but that's okay. So I'm going to go in here. I'll erase this. And so I'll just paste that thing that we copied. This is inside of our while loop. So basically we're going to get all of our files. We're going to get all of our files and then store them in this variable. And then for each of those files, we're essentially going to calculate the file hash for each one. That is these files in here. We're going to calculate the file hash for each one of these, and then we're going to compare it, and then we're going to compare the hash to what's in our dictionary, what's in our baseline dictionary. So instead of this, I'll just comment this out. What's a good way to do this? My brain's getting tired. So we'll say, actually, let me run this so I can remember what this hash object looks like. So I'll run this code. This is just going to get all the files and then calculate the hashes for each one of them. So I'll run this, and then I will check out what the hash looks like again, just so I can remember. Looks like it has the hash and then the file path. Okay, so we can do something like, first we're going to check to make sure that the file hash exists in our dictionary. So we'll say something like, we'll say if file hash dictionary hash.path, if this equals null. So if this equals null, then we'll know that a file has been deleted. A file has been deleted. Notify the user. So we'll test this out first. So we'll say write host. We'll say hash.path. No, we'll say, what is it? No, sorry, this is not right. If this equals null, it means somebody created a file that doesn't exist in our dictionary yet. So we'll say like a new file has been created. We'll say a new file has been created. And then we'll say hash.path has been created. And we'll make this green, I guess. and we'll just test this out. So I will run this, we'll say B, and then I will make a new file in here, and it noticed that a new file was created. So I'll just like delete this again because it's different from our baseline. You'll notice it stops scrolling. So I'll just make a new file. Very interesting. Rename it. ABC has been created. Get rid of it. It's not on our baseline, so nothing is here. Okay, cool. So now this block of code, notify if a new file has been created. So we're going to say notify if a new file has been changed. So if a file has been changed, if our dictionary hash, if the hash of this path doesn't match the one in our dictionary hash, then we'll know that the file has been changed and we should like notify the user. So we'll say if, we'll take this. So this returns a hash file, I believe, or a hash. So let me just like make sure of this. I'll just highlight this and run it. Yes, it returns a hash. So we'll say if the hash at this path matches this hash's hash, the file has not changed, else the file has been compromised. Notify the user. So we'll say right host, and we'll say the name of the file or the path has changed, and we'll say like foreground color, maybe some kind of red, I guess. We'll just like see what this looks like, I guess. So I'll run this. We'll say B for begin monitoring, and I'll like edit one of these files. And after I edit and save it, it should alert us. So I'll just put a space and I'll save this. And it says e.text has changed. So if I put this back and save it, it should revert the file hash to what it was before, and you can see it has stopped scrolling. So if I add a file, and then I see we have like a logic error in here. So let me just delete this. So it looks like my brain is dead. So maybe we should like put this in here. If it's not null, we can like add it in here. Let me just try to run this again. I'll say B, I'll make a new file. Cool. So that looks like it's working as expected. So if I delete this and if I change this, for example, save it, complains, D has changed, put it back, stops complaining. So cool. Maybe I'll make this like yellow or something. And then last thing we have to implement we have to see, and the last thing we have to do, we have to implement a way to check if a file has been deleted or not. So to do that, so let's like think this through a little bit. So I'm so tired from making YouTube and like talking too much. So basically I'll just make a function that checks if any of the files have been deleted. So basically, if a file has been deleted, if our baseline, we have to compare the baseline to like what's in the actual folder. So we'll check each path in the baseline to see if it's in the folder. So we'll say like, maybe like get file path A, like test path A, test path B, test path C, like whatever is inside of our baseline.txt. And if any of those like come back false, we have to alert that the file has been deleted essentially. So I'll just make a new, I'll just do it here. So I'll say what should I say? This is so I want to do like for each for our dictionary. I'm not sure if I can do that. I think I can. That wouldn't make sense if I couldn't. Let me stop the program from running. So I'll say, I think I can do that. For each key in blah, 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 dot keys. I believe I can do this. Let me make sure. It should spit out all the keys in this dictionary. So let me run this, and it did. Great. So this should be fairly straightforward. We can just say something like test path, key. We'll say file still exists, or we'll say baseline file still exists equals test path. And then we can say like, if not, baseline file still exists. So if the file doesn't exist, one of the baseline files must have been deleted. Yeah, right. Notify the user, something like this. We'll just write host, and we'll say key, which is the file path we're inspecting or checking if it exists. We'll say has been deleted. Deleted. Foreground color. This one should be red. This makes more sense. Or maybe we'll see what it looks like. I don't even know if this is going to work properly, but because I'm so tired already, but we'll just try it out. So what would you like to do? Collect new baseline, begin monitoring. We'll say B. We want to start monitoring, and our program is running. So let me open up another window so I can move the files back and forth to simulate deleting them. So I'm going to delete E. I'll just put it in here. Oh, it's spamming. Oh, it shouldn't do this. Well, it works anyway, but I'll put it back. So let me stop this. Let me make the background color brighter so I can read it. Let's see here. So this is Oh, this should be, I'll bring this outside. I think that's why that's happening. So it's inside this big for each loop. So I'll just do this. I'll do it separately. I'll evaluate this separately from the rest of the files. So let's try this again. Oh my gosh, what the heck? Okay, let me run this. B, check, evaluate. So I'll bring our trusty files out here. I'll delete E again. E has been deleted. It's been deleted. Oh my God. So I'll move it back. Stops complaining. I'll change E. I'll just add an extra E. I'll save it. E's been changed. So shit. So I'll put it back. I'll make a new file and I'll drag it in there called F. I'll just do this just so I can, you know, whatever. Bring F, bring it in here. F has been created. I'll move that out again. Yeah, this looks like it is good to go. So I'll just play with this like a little bit more. Add an A, save it, remove it, put it back, bring A out, notices, complains, put it back, and good to go. Yeah, so there's our working code. It was probably hard to follow this just because like different people like think differently when they program, but that's kind of realistically like how I would go about making a FIM, or like a really simplistic FIM. And hopefully like the idea of integrity is maybe more solidified in your head now. Just like checking files, making sure that the file like maintains its integrity, like making sure that it doesn't get changed or deleted or anything like this. And if it does, raise some kind of alert so the analyst can like look at it or something like this. But I'll make the source code available in the description if you want to check it out. Some ways to like improve on this code. It's like quite bad. The code is like quite bad. It works. It works well, as you can see, but you know, if something like changes, like for example, you know, say that you tell it you want to start monitoring the baseline even though a baseline doesn't exist or something like that. There's like a lot of situations where this code could like break like really easily. So something you could do, like you could take this, like if you want to take this and make it better for yourself, if you want to take this code and like essentially make it better and like put it on your resume or something, you could make it your own by kind of adding fixes for it, like letting the user pick like which folder to monitor the files in, and like do like recursive file monitoring that like dives deep into the file structure and like monitors all the files in a given folder. Or you could add a lot of error checking, like if the user wants to start monitoring files but there's no baseline, add some error checking that and some flow control that redirects the user back to like create an actual baseline. Or instead of simply printing stuff to the screen, you could figure out how to make it email you with PowerShell, or like implement with like Twilio API to send you like a text message or something like this. There's like all kinds of ways you can improve on this and make an actual like useful FIM. But this is just like a really basic proof of concept. That's all I could manage to code while like making a video of it and like doing it live. But yeah, I hope this was useful for you and hope you learned something. Definitely take this, you know, rework it, put it on your resume, like make it your own. But yeah, thank you so much for watching. Again, I read and respond to all comments, so please like leave comments and criticism about this. People like to pick apart other people's code, so please feel free to do that in this video. I'd appreciate it. I do have a Patreon if you feel like supporting me. But yeah, thank you so much for watching. Hope we learned something, and we will see you in the next video. Bye bye.